Anyway, I thank all of you who have come here, Mr. Roy, Mr. Shastri, Mr. Kailash, Mr. Kablani, Mr. Shastri, Mr. Norana, Professor Krishna Indra. I feel NP, National President, joined Anil Sir. So, who have everybody. Uh, uh, I thank everybody for coming to this seminar, which IIP is conducting after a pretty long time. After our first November program, we could not make any other program. So I thank Mr. Mukesh for accepting our invitation and being a faculty for today. So as regard Mukesh, he is very popular member of our vice member of our IIP Maharashtra chapter, and he has been the past chairman of IIP, and of course he is a very experienced engineer. He is an electronics and a telecommunication engineer and has specialized in vibration monitoring techniques and tools for over 3 decades. He has been associated with the French company Equion, a leader in conditioning monitoring instrumentation. He has wide exposure in application of conditioning monitoring techniques for process industry. He also specializes in techniques for acoustics and sound system for emergency purpose. He has widely traveled on business assignment to Germany, France, Canada, and USA. He was a regular guest faculty at NITI, Mumbai for the EDP programs on maintenance conducted by NITI for industry. He is a life fellow of IIP and a very senior member of IEEE USA. So with this short introduction, I feel we can definitely gain a lot of knowledge from Mr. Mukesh experience, and whatever vibration technology knowledge he has, practical as well as theoretical, it will benefit all the participants who have come here. And I once again thank all of you for joining here. And I request now Mr. Mukesh Shah to kindly take over and start his presentation. Thank you very much.
Thank you, Ashokji. And hello to everybody here. So I have a pleasure in sharing whatever I have gained over in almost 3 decades in the field of predictive maintenance. And I will try to share whatever best I have in my mind. I have prepared my presentation on those lines, and I think at the end, of course, we will have the question answers, but in between also, I would probably at the logical time, I will try to ask you for the questions if you have. Also, if you have some questions which comes to your mind, you can put it in the chat box, and we'll try to see that we answer all your questions today, or else in case if some questions require further information, I will get back to you. That's how we will begin. So we will talk about this predictive maintenance, and I normally say machines talk. Let's listen, we have to understand the machine, what is it talking about. So what I'm going to show you here is, okay, whatever Mr. Jadhav said just now, a brief about my background, which I already so I'll skip this further. Then what are we going to talk about today? So we will start with different types of maintenance which are being followed, and then which maintenance to choose. Then we will have the cost and benefit of predictive maintenance, the predictive maintenance technology by itself, various types of predictive maintenance technologies like aerograph, wear debris analysis, vibration monitoring. We'll focus more on vibration monitoring because that is one of the most popular ones. And then we will talk more into it about what is the vibration amplitude, what is the standard ISO 10816, what is trend analysis, what is frequency analysis, what is Fourier transform, what is machinery vibration diagnostic. There is some kind of a diagnostic guide, so we'll talk about it. I've tried to put in some case studies also. So we'll talk about a couple of case studies, which are actual case studies, live case studies. And then a little bit about what is a vibration monitoring instrumentation. How does it look like? What do you say? What do you see in that? So this is what, and I would consider this as kind of an basic information. Even if you don't have any previous information or knowledge about vibration monitoring or predictive maintenance, this should be fine. And then whatever probably we can do is we can go further in maybe subsequent time. Sometimes we can have second level or third level of courses, or third level of seminars. So today is going to be the basic one. So we will go ahead with that. So now let's see what types of maintenance are there, So if you say corrective maintenance, or some people call it as breakdown maintenance, that means if I have a machine which is running and I maintain it only when it is required. So when it fails, I will attend to it. So this is called as corrective maintenance or breakdown maintenance. Then there is something called as preventive maintenance. Most of us who have worked in the field, we know that we have preventive maintenance schedules. So let's say every month I will stop this machine and then I will overhaul it, and then I will start it again. Or you will have some kind of a schedule for every machine. So you will shut down that machine, or you will take it up for maintenance and then put it back again in service. So this is preventive maintenance. Then we have something called as conditional maintenance, or we call it as predictive maintenance. The idea is that you monitor the condition of the machines, you monitor the condition of your production machines, and then if required, you will maintain it. Otherwise, you will allow it to run. So you will allow it to run until you have to really maintain it. Otherwise, you will keep running. So these are the type of maintenance. Now, the next one is, which machine should I choose for which type of maintenance? So for example, after you finish today's, this webinar, and you say that from tomorrow, I'm going to maintain my ceiling fan by predictive maintenance. I'm going to take a vibration meter. I will take a vibration reading. I feel that maybe that will be like, what are you doing? Your wife will say, what are you doing? Because you cannot buy a vibration meter which is costing maybe a lakh of rupees to maintain a fan which is, 3,000, 4,000 rupees. So you need to know which machine you should maintain by which technology. So I have put this on a flow chart. So you say, is the breakdown important for production or security? For example, the machine breaks down, it is going to affect your process. If it's going to affect your production, then naturally it is important, and you must look at what to do with that. If it is not so important, you just say whether the cost of breakdown is acceptable. If the cost of breakdown is acceptable, then please go for only corrective maintenance or a breakdown maintenance. A fan at home is, I think, a classical example. So if it breaks down, then you will attend to it. Otherwise, you don't have to really attend to it by any other type of maintenance. If no, the breakdown cost is not acceptable, or your breakdown is important for production or security, then you have to look next. So, like for example, the same machine sometimes might not be very important, but the same machine employed for something different can be important for security purpose. For example, a tube light in an operation theater is really important. Whereas a tube light in your living room or in your bedroom, that's not really that important. You can wait till it breaks down. Whereas in a theater, in an operation theater, you need to see that it always functions when you need it. So it's more important. So you have to decide accordingly whether you need to then go for preventive maintenance, or if there is a possibility to apply the monitoring. And by applying this monitoring, if you are able to save the cost, if you are going to gain something out of it, then yes, probably it is right candidate for doing the predictive maintenance. So this is how you will have to roughly decide which machine, which maintenance, and then apply these techniques for your plant, for your different machines. Now you will have to look at the cost and the benefit of any maintenance that you do. So when we talk of predictive maintenance, what is going to be your cost? Cost is going to be the capital cost of the equipment. It is going to be the training of the staff. You will have to spend money on that. You will have to decide and rework your maintenance procedures. It will also probably cost some money. So these are going to be the costs which are there. At the same time, what are the benefits which you will get out of it? So what the benefits you will immediately get are, there will be more time between shutdown. So maybe you don't have to take the shutdown as frequently as you were doing earlier. There can be no unexpected breakdowns. The machine will not break down unexpectedly. You're monitoring it on a regular basis, so you will know, you can expect when is it going to break down. So that means if you planned your production, there will be no unprecedented breakdowns and the production suffering will be reduced or production loss will be reduced. Less secondary damages. Supposing your bearings have worn off and you still keep running your machine, probably your shaft will have a problem or probably your foundation will have a problem, So those kind of secondary damages can also be prevented. It also means that there will be a better quality of maintenance and better quality of life for the maintenance engineers. Right in time of spares inventory. If you know that when the bearing is going to be required, maybe you will get it right in time so that you save money on holding the stock. No wastage of spares. Now you can analyze what has gone wrong rather than doing any kind of trial and error. And then you will be able to repair your machine with the minimum number of spares that are required. And shorter repair time because you are now able to diagnose what is wrong. Should I attend to the bearings or should I attend to the foundation or whatever? By monitoring these things, and you will be able to achieve shorter repair time. So these are the benefits that you have. Now, what are the different techniques with which you can do predictive maintenance? Some of the process parameters, you know that on your process machines, you will have temperature monitoring, you will have pressure monitoring, you will have flow monitoring, you will have current monitoring, etc. This also gives you some idea about the health of the machine. If the temperature is rising, then you know that something is wrong. For example, in a cement plant, I've seen that those cement kilns, they are lined up with those refractory bricks. If some of these bricks are worn out, the surface temperature of the kiln starts increasing. And this is a good idea that will tell you that there is some problem inside the lining, and then I must attend to it before it goes out of control. Similar kind of, other parameters, process parameters you can monitor, and you can find out what is the problem with the machine. The other techniques which are quite popular, ferrograph, for example, is a graph which you take by for the ferrous particles, and this will tell you what is the wear and tear of your machine. Similarly, wear debris analysis. These are other kind of particles, which wear out, and this will be can be also analyzed, and you can find out what is the condition of the machine. Thermal imaging. Currently, we use this thermal monitoring for our body temperature, for our detecting the temperature of the body for the COVID purposes. This thermal imaging is also very popular. And this can also be used to do some kind of predictive maintenance. And of course, the most popular one amongst all this is vibration monitoring. So vibration monitoring, we will go more in details to understand what it means. So I will now tell you about what is ferrograph and wear debris analysis. So primarily what happens is this lubricating oil is most likely present in almost every type of rotating machines or reciprocating machines. And this will carry any kind of ferrous or wear particles. So, ferrous or any other type of particles, which will start wearing off. So supposing if you take the sample of this lubricating oil, just like you will draw the blood for blood analysis, similarly, you will draw the lubricating oil. And then if you analyze, you will find out that there are some particles in it. And these particles will give you different concentration, different sizes, and different shape. And with all this, you can come to a conclusion that what are the parts which are wearing off, at what rate they are wearing off, and how long will it be before it really wears off so that I have to shut down the machine. So such analysis can be done for all the types of ferrous particles and other particles with which your machine is made of. The advantage of this is that it gives a very early detection of the wear and tear, and it also has a failure pattern. So if you analyze this failure pattern, you can predict what is the life of this machine or what is the life of this particular component of the machine. The negative side or the flip side of this is that it is capital intensive. The, let's say, typical oil analyzer is going to cost something like, starts from something like about 2 to 3 crores and then crores. And then it is difficult and cumbersome to collect. But yes, this is a very, very useful technique. For example, all your flights, all your aircrafts which are flying, so you have to do some such kind of an analysis. So all these aircrafts, approximately, if I know right, about 200 hours of flying, and the oil is sent for an analysis. And this lab is installed here in Mumbai. In fact, many years ago, I have visited this at the Air India facility, and they do this kind of analysis, and they will be able to predict any kind of problems which are going to come up in that particular engine. So, for such kind of applications, this is good. You can use this kind of a, technique. It's also used very frequently for many machines which are very critical for production. For example, in Reliance, in their PFY plant here in Patalganga, they said almost, I would say about 10 years ago, I remember they had said that 1 hour breakdown of a particular section of a plant is costing them something like about 30 to 40 lakhs of production loss. Now for them, this kind of a machine will be good. And one more good part is that there are some agencies in India also who offer you the services. That means they will come, they will collect the oil sample, and they will do the analysis and give you the report. So even such services are available. So depending on the type of machine you are using, depending on how critical it is, you can decide whether you would like to go for this kind of a program. The thermography. What you see here in the picture is a thermal image of 3 bus bars which are connected to RYB, for example, in an electrical connection. And you can see that the one which is in the middle, it is with the red kind of mark, which is hot. That means there is something wrong in that place. You can see that different colors are there. So different color represents different temperature levels. With this kind of a thing, you can make an analysis of something which is going wrong, at which location it is going wrong. So maybe you have to take the corrective action at that place. So as I told you about the cement plant, for example, if you take the picture or thermal image of a cement kiln, you will see that there are certain hotspots, and these hotspots means that at that place the refractory lining is wearing off. So depending on how fast that is happening, or you can trend it and you can find out when I have to replace my lining. So accordingly, you can take the shutdown and you can repair that kind of lining. So such things can be done. It's again another capital intensive equipment, and it is not really very useful for mechanical damages in early stages. After late stages develop, the temperature would develop and you will be able to find out something about it. But then there are other techniques with which you can do a little bit earlier kind of diagnosis for the mechanical damages, the rotating machines or reciprocating machines. The next one, and the most favorite one, for me, I really love this topic. So vibration monitoring. So vibration monitoring has a lot of advantages. It is easy to collect. We will show you how easy it is. It provides fairly early detection. It also has the failure signature. It's a suitable tool for alarm monitoring, predictive maintenance, and diagnosis. So these are the things which we will touch upon. We will be talking about what is alarm monitoring. We'll be talking about what is predictive maintenance using vibration monitoring, what is diagnosis using the vibration. Any questions so far?
Okay, it's just 1 minute. Huh?
Yeah.
I'll be muting everyone because I believe there is some kind of a disturbance.
Yeah.
And then you'll have to unmute yourself.
Okay.
Yeah, I think we have done that.
Okay. So I'm audible, I hope.
Yes, yes.
Okay. So I would go further and maybe we can keep the questions at the last, or do you feel like...
Mukesh, I have a
Yeah.
question for you.
Sure.
Just go back to the testing laboratory side. Just go. You said that, analysis of VR pattern.
Yeah.
You said that there is a laboratory in Mumbai. Is it under government, means Air India control, or
Yes,
is it a
it's an
private?
Air India. It's an Air India laboratory.
Okay. There is
Yeah.
no third-party laboratory for this?
There is one private laboratory which I know is in Hyderabad by a company called Predictive Tech. I think I should have some information about them. I have not met them for many years now, but I remember that they have this service available, wherein they send people to collect the samples and they provide the service. I'm not sure about Air India whether they provide the service, but Air India has a lab.
Okay. No, my question is for general awareness.
Yeah.
That if a small company wants to send a sample for this testing,
Yeah.
what you are saying as paragraph and we have
Right.
done this analysis.
Correct.
So what will be the, because we are not interested in machine cost, but what
Yeah.
will be the testing cost? Suppose a small company wants to analyze it.
Yes. I frankly speaking, at this moment, I don't have much idea of what is their latest cost. This company in Hyderabad.
This oil cost is around 25,000 rupees, sir. In the 2000. Now I don't know. Just for information.
Okay, Mr. Nageshwar. Okay.
Yeah. I done lube oil analysis done it in 2000, 2005. It is cost 25,000 rupees for each sample. But it is in Singapore, not in Hyderabad. I also don't know Hyderabad party.
No, I think Hyderabad was quite cheaper, Mr. Nageshwar.
Maybe India when the latest in the past I've done like that.
Only thing what they were doing was, instead of giving you a one-time service, they would say, please enter into a contract so that you have samples collected at periodic intervals, and then they would give you kind of a trend and kind of analysis and something like that.
Okay,
and then maybe it becomes more viable for them to send people to collect and do the service that way. But if I remember right, maybe about 10 years ago or something, they were charging something like 1,500 rupees per point.
Per point.
Per
the loop
machine.
analysis, so many analysis is there. BDV, so many analysis. That is 25 analysis are there that they are doing. But where these sets are replacing loop oil for frequent replacement. We are doing like that.
Okay.
Thank you very much.
No, why I was asking this? Because sometimes cost is prohibitive, and instead of getting it tested, they can just go for a replacement, buy a good oil. So that analysis is must. Maybe you can incorporate it.
See, oil, replacing the oil is one part of it, but if there are some parts which are wearing off, let's say your piston and piston rings are wearing off, even if you replace the oil, yes, maybe the vibration level will come down for that moment. But then the original problem or the root cause of that particular thing is piston rings wearing off. So maybe at a time you will have to replace the piston rings, and then you should know when are you going to replace it. So this is what will be more important. Sure. Yeah, oil can be, of course, replaced. Oil replacement will not be that costly.
No, once they do our oil replacement, maybe after 1 month they can send the sample. Then they may come to know.
Yes.
Excuse me, sir. In this, one more drawback also is there. Whenever you replace a defect in the oil, there carryover is there, wear and tear is there. No, total system has to flush it once again. Lube oil, fresh lube oil, flush it again to recharge it. That also costing more.
Correct. Very true.
Okay, you can continue.
Okay. So I go ahead from here.
Yeah.
So vibration monitoring. Now I will give you some example, which is our normal medical analogy I would put in. So for example, you are normally normal. So your machine, your body is normal, it's running. Then what you do is you have some signs maybe, and you would like to take your temperature. So what you would do is you will use a thermometer, a clinical thermometer, and you take a reading. What you get is one value. So this is a number. So, and there is something which is a standard. This standard tells you whether your fever is, you have fever or you don't have fever. And if you have fever, how severe is your fever? So, but there is a one value. This is your degree Fahrenheit or degree centigrade, whatever you're measuring. And if it's degree Fahrenheit, you say, okay, 97.3 is a threshold. So this, I don't have temperature or I don't have fever, I would say. Then above this, I have fever, but up to 100, it's okay. I can still, take a crossin or something. And these days, of course, you say that if the fever is even low fever like 100, then maybe you have to do a COVID test, something like that. Or if it's above 102 or 103 or something, then you need to probably get admitted to the hospital. Can we mute if somebody is unnecessarily, there is some background noise, please?
Yeah, 1 minute.
KN Gupta, please mute.
Okay, so now when you take this body temperature, you know that you are not well, you have fever, but it is not enough for diagnosis. You just know that there is fever, but you need further diagnosis. Now, further diagnosis, what you do? So depending on how are the symptoms, whatever the doctor will recommend you, that please go for a blood test or maybe go for an ECG or something like that. Similarly, here also what happens is you take the vibration reading, you use a simple vibration meter, and you take a vibration reading. It will give you what we call as vibration amplitude. I'll tell you more about vibration amplitude later. It will give you one number. This number you will come to know whether the machine is okay or whether there is some problem. And if there is a problem, how severe is this problem? What is the number? And then, like I said, that for a human body, we have a standard. It's a 97.3 is okay. 97.3 to 100 is not okay. You are in alert zone. And then above 100, you are in danger zone. Something similar we have here also. Only thing is, in case of human beings, we are all the same machine. So standard is one for all of us. Whereas in case of production machines, there are different types of machines. Some might be small motor or a fan or something. Some might be a bigger compressor or something. So you have different standards for different machines. So there is something which is called as an ISO 10816, which is a standard. I will show you that standard also. So there you say that, okay, this type of machine, this is my normal limit, this is my alert limit, this is my danger limit, things like that. And then you will compare and you will come to know that machine is okay or it is in a problem. Once you know that it is in a problem, then you need to know further. You will have to find out why. Why is this vibration? So that is where you come to further analysis, which is very frequently called as frequency analysis, or it's also called as spectrum analysis, or it's also called as FFT. I will tell you all this further. Now here, it's going to be a graph. So let's say a doctor takes your ECG. ECG is a graph. And from this graph, doctor will make an analysis that how is your heart performing. Similarly here, you will have a graph. And this graph is vibration amplitude on y-axis. And on x-axis, it is frequency. So we call it as a frequency analysis plot, or we call it as a spectrum, or we call it as FFT spectrum. And then from this spectrum, you can make an analysis to find out that in your machine, whether the bearings are getting worn out or whether the bearing is generating this vibration, or whether the balancing of the rotor is required or unbalance of the rotor is generating this vibration, the foundation is generating this vibration, or gear mesh is generating this vibration. So depending on type of defect, or maybe multiple type of defects, you will be able to make an analysis to find out what is wrong with your machine. So going further, if you see these waveforms, what you see is I've taken simple sine wave. In practical life, it will be more complicated than this, but to understand this, we can say, let's say sine wave. So if you see the top one, the red one shows you an amplitude. That means how big is this peak? This is telling you what is the amplitude of this waveform or the signal. And on the x-axis, what you see is the repetition. So for example, if you see this green curve, and the red curve, everything is same except that the heights are different. So they have different amplitudes. They have different amplitudes. The red one is having a higher amplitude, whereas the green one is having lower amplitude. Okay. Now, what is vibration? Vibration is motion. Yeah. Vibration is motion. Thus, the amplitude of vibration are similar as motion. So, in any kind of motion, you will have displacement. That means, let's say if you say that the body is at rest, there is some point, and then when it starts vibrating, it goes to one extreme, then it again comes back to the same rest position, and it goes to the lower extreme, you know.
RP, please ask KN Gupta ji to mute his mic. Gupta ji, आपका mic mute करो. Okay, thanks.
So this displacement is mathematically denoted as x. Okay, we will not do too much of mathematics here, just for an understanding. So you say x is my displacement. Then if you have a motion, then you will have velocity. Now what is velocity? So rate of change of displacement. Rate of change of displacement is velocity. So dx by dt, denoted in mathematical terms. So rate of change of velocity is this. I mean, rate of change of displacement is velocity. And if you have displacement velocity, you will also have, in a motion, you will have acceleration. So acceleration is rate of change of velocity. So rate of change of velocity is acceleration. And mathematically, it will be denoted as d2x by dt square. So we are not going to do any calculations here. Why I mentioned this out here is that if you now measure, for example, displacement, and if you take a derivative of this, you will be able to get velocity. You'll be able to calculate velocity. If you take the double derivative of displacement, you will get acceleration, or the other way around. Supposing if I measure acceleration, if I integrate it, I will get velocity. And if I double integrate it, I will get displacement. So they are correlated. They are related with each other. Okay, just you can remember this much. Next one. Now I told you about the standard. So vibration amplitude has a standard. In fact, I should show you my next slide. I think the order is a little bit problem. This is the first thing I should show you. So the standard example of ISO 10816, it primarily is defined for mechanical vibration of machines with operating speeds from 600 to 12,000 RPM. This is where it is quite effective, and this is where it is normally used. I told you about the vibration, displacement, velocity, and acceleration. The value it shows, the value it has formulated itself is on RMS value of the vibration velocity. Okay, so it measures the vibration velocity. Your meter will measure the vibration velocity, and against that, this is compared. And the range is from 10 hertz to 1000 hertz. Okay, this is the frequency. And then alarm value. So again, I will show you the next slide wherein those different color chart is available. Here you will see that the machines are classified in 4 different classes. So class 1 is simple individual component machines, and up to 15 kilowatts. This is a typical one. Medium-sized machines is class 2. This is from 15 to 75 kilowatts electric motors or 300 kilowatt engines on special foundations. Then large prime movers, like which are on heavy and rigid foundation, is class 3. And the prime movers, like let's say power station generators, these are the large prime movers and mounted on relatively soft and lightweight structures. So these are class 4 machines. Because these are divided into different class, because let's say a machine which is in class D, or class 4, the value which is acceptable if you see, for example, the last or the rightmost column, which is class 4, and this, what you see out here, I think the arrow is visible. So then this green value for class 4 machine is already in a yellow value or higher area yellow value for class 1 machine. So vibration values will be, or the safe values are different for different size or different types of machines. Okay, so you have to find out which machine are you monitoring, what will be your class of machine, and accordingly you can follow that particular column. So for example, if I take class 1, the RMS value 0.71 millimeters per second is green, which is safe, it's okay. Now B is, the value started increasing. C, what we call as still acceptable value, but it is you are in alert zone. And then D is something which is unacceptable. Yeah. So here you cannot use this value. I mean, you should not run your machine in the area when you are in the D zone. So this is how you can find out that my machine is okay up to, let's say, 1.8 millimeters per second if it is class 1 machine. 4.5 is up to that, I can still run it. But if it is above 4.5, then I should not run that machine. I should maintain it. So this is how you will read this vibration severity chart according to ISO 10816. This is one of the most popular standards which are being followed. And there are instances wherein you may have some machines which are special. You may have some standards which you would like to develop yourself. You can also do this kind of, alert, or I would say green, yellow, and red zones yourself by taking some kind of statistical tools. What you should do is take number of readings on a good machine, and then by statistical calculations, you can say normal value plus standard deviation one time is alert value, and 2 times the standard deviation is the danger value, something like that. So this kind of a standard of your own you can formulate, or else you can use one of the standard which is available readily. So after you measure the value, what you can do is simple. If you don't have anything else, you can use a standard Excel file and you can plot these values versus date. So you can see that there is a trend. Now you see that the trend is, slowly the value is increasing. And at a particular date, you have reached the alert level. So now if you find that you get a shape of the curve, you can extrapolate this curve and you can predict that I am going to almost attain my alert level on this particular date. And I would probably attain the breakdown level by this particular date. So this period which you get between the alert level and the breakdown level is the time period for you to prepare for maintenance. That means you can order your spares, or you can plan your maintenance, you can plan your shutdown, etc. So this is how you will be able to find out when can I, or I would say you can predict when will I have the alert level or when will I have the breakdown level, and how should I plan my maintenance. So this is what they call as trend analysis. Okay. So is amplitude of vibration clear? Then we can go to the next one. That means after you have determined that there is a problem with the machine, you now want to know why. What is the problem? Whether it is bearings, whether it is foundation, whether it is loose, I would say loose connection somewhere, or whether it is misalignment, or whether it is loose belt somewhere, something, depending on your machine. So you need to find out. And for finding this out, frequency analysis is something which is going to be of our help. So what is frequency? So rate of occurrence of an event is frequency. Yeah, we can say that I get the bus at every 15 minutes. Frequency of the bus. Similarly, I can say here, the graph which you see here in green or red, you see that this particular pattern is repeating at a particular time level. If I plot it against time, I can say this is generating 50 cycles per second. Right? So that means I get such 50 peaks in 1 second. this is my frequency. Or I can say I get this 3000 cycles per minute. Yeah. So 3000 cycles per minute is nothing but 50 cycles per second. So, but normally in case of a machine, you are talking about RPM. RPM is revolutions per minute. So normally in case of machine analysis, we normally talk of frequency in terms of CPM or cycles per minute rather than hertz or cycles per second. But either way, it's okay. Now, different vibration defects produce different frequencies. This is what we are going to analyze. So now in this graph, what you see is there are two waveforms. The top waveform, you are seeing time versus amplitude. Now, if you see the repetitions, number of cycles in that particular defined time period, here, let's say this is my defined time period. Here I have, let's say this is my 1 cycle, this is second cycle, this is 3 cycles. Here's in the curve below, that is green curve, if you see this is repeating much frequently. Yeah. So here I can say that the frequency of green wave is higher than the frequency of the red wave. So F1 is less than F2. The frequency of red wave is less than the frequency of green wave. Okay. At the same time, if you see the time period, that means this is the time period. So here the time period, the TF, I would say T1 is higher than T2. That means frequency and time are inversely proportional, or 1 by T is equal to F, or F is equal to 1 by T. Now, you see here, you see two parameters. One is the amplitude. So amplitude of the red waveform is higher, whereas the amplitude of green waveform is lower. Frequency of red waveform is lower, whereas the frequency of green waveform is higher. Okay. So these are the two different parameters you're measuring out of this. Now, instead of time waveform, if I plot, for example, if I were to take this waveform, I will say the amplitude of, let's say, first wave, red wave is, let's say, 5. And the amplitude of green wave is 2. And let's say the amplitude, the frequency of red wave is, let's say, 50. And frequency of green wave is, let's say, 1000. Yeah. So now if I plot it here, what I get is, I get a peak. Depending on the amplitude of the first waveform, I get a higher peak because the amplitude is higher there, but the frequency is lower. Whereas the second waveform, if you see, this is a lower amplitude, but higher frequency. So what I now get is a frequency spectrum. That means I get a plot of frequency versus amplitude. Okay. Is that clear to everybody? Anybody has any question?
No, since they are all on mute, they may not be able to ask you now.
Okay. So you can probably put it on your chat box, or even please keep it with you, and we can address this at the end. Okay. But I hope that it is clear that you have understood what is frequency plot versus what is this time plot. This is time versus amplitude. This is frequency versus amplitude. The relation between time and frequency is F is equal to 1 divided by T. That means you can calculate the time waveform. Once you can calculate the frequency waveform moment you have the time data available. Okay. Now I go further. Now, how do I calculate? Now we just saw we cannot do this manually every time. So ultimately, these calculations are something which is mathematically possible. So this gentleman whom you see here is Fourier. I think most of you will remember Fourier transform from your engineering first year mathematics. Okay, we don't have to really go back to those formulas. Don't worry. What I've shown here is, supposing you have a complex waveform. See, what we saw earlier were simple sine waves. Whereas actually the machine will generate something like what you see here is a complex waveform. And this complex waveform, what Fourier described is any kind of periodic waveform, any kind of waveform which is repetitive in nature, can be broken down into series of sine waves. This is what is Fourier theorem. So mathematically, it is possible that you can divide a complex waveform, a complex repetitive waveform, into series of sine waves. So that is what is shown here. So you have a complex waveform. This is equivalent to this one, waveform number 1, plus waveform number 2, plus waveform number 3, plus it goes on, depending on how complex the waveform is. For example, if you have a square wave, in that case, it will be an infinite series of sine waves of different frequencies. All added up together will get you a square wave. Okay, so this is what you can divide, or you can transform a time waveform into a frequency waveform, and this can be done mathematically. Now, as long as you are able to do anything mathematically, in today's terms, you can do this, or this calculation can be done by any computer. Now, any computer means today we can say any instrument that you buy will be able to do this by what is known as frequency transform or FFT analysis. It will convert your time waveform into frequency waveform and plot it on your screen. So if it is a mathematical calculation, any computer, any microprocessor, anything will be able to do this. And that is what is the advantage of using this FFT transform or FFT, or rather Fourier transform, to calculate the frequency spectrum and display it on your screen in a very small packet or in a very small box. This can be easily done. So today you get a vibration analyzer which are hardly maybe 500 grams or a kilo, and you have a lot of things packed into it, and you can just take it to the field, battery operated, and you can analyze a machine. Now, just to give you in relation to machine, how does it look? So for example, I've taken a simple example of a machine where you have a motor. This motor has a coupling. This coupling, you are coupling it to a gear train. So let's say there are 2 gears here. And then you have a bearing and you have something to move, maybe some fan or something like that. So this is what is moving here. Now, if you take a vibration reading, you will get different frequencies due to different components. Just some rough ideas. For example, a motor which is running, let's say, at 1500 RPM. Now, 1500 RPM means it is 25 Hertz. So if it's 25 Hertz, I will see one peak here, depending on how much vibration the machine is producing. I will see the peak here, and I will see the frequency here. So let's say this is generated by this motor. This is a coupling. Coupling might have, let's say, some kind of a misalignment or something like that. So it will generate another frequency here. Let's say there is a fan like this or something which will generate another frequency here, depending on what is its RPM. This particular peak will be, displayed. The gear will generate generally a higher frequency. So you have a higher frequency component here seen because of the gear. Similarly, let's say bearings will generate high frequency. Depending on the type of the bearing, you will have the frequency generated. And this will also be plotted on the same plot. So if you see this plot, you will be able to see that there are different frequency components, there are different amplitudes or vibrational levels. And then, for example, let's say this particular bearing peak is very big. Then you know that this bearing is having some problem. Yeah, you have measured that there is vibration is high. And then I make an analysis like this. And then if I said that this peak is higher, then I know that this is because of this bearing, which also means that I should predetermine, I should know what will be the frequencies generated by my machine. Like a doctor knows that what will be the frequency generated or what will be the waveform generated by your heart. They talk about P, Q, R, S, and T waves, on your ECG. So he knows that T should be so much. But if T is higher, that means he knows that, what kind of element you have with your heart. Similarly, you are a doctor. You are now a machine doctor. So with this ECG, you should be able to find out which part of my machine is in a problem or how severe is this problem. And now, for example, you took this reading today, machine is running fine. After 1 month, you took another reading and you compare them. and you find that this particular peak is growing higher. That means compared to last time, this has gone higher. That means you know that there is some bearing wear is happening. And you may know that this is still okay. I can run the machine for another 15 days and I will take a reading again. And then if I see that the peak has grown further ahead, that means I now confirm that, the bearing is wearing off. And rate at which it is wearing off can tell me when am I likely to have a bearing failure, or when am I going to need my new bearing, which I must replace. That means if you know that the bearing supplier is going to take 1 month to deliver your bearing, please order it now, because after 1 month, you might need the bearing replacement. By that time, your bearing would have gone off. So you get enough time to order your spares. You get the spares just in time. At the same time, you're running the machine, knowing that it is going to fail after 1 month. That means you're prepared for it. And then you will take a shutdown at that time and you will replace the bearings and the machine is up again. So you will not have unprecedented shutdowns. You will have just-in-time spares and you will have enough time to prepare for maintenance shutdown. Okay. So this is how the predictive maintenance will work. So before I go further, again here, I hope you have understood this. Now, what I'm going to show you is a chart or a table which talks about what are the different frequencies generated by different components of machines. So for example, one of the most common problem in vibration would be unbalance of the rotor. Yeah. So this unbalance of rotor, the dominating frequency is 1 time the rotor speed. It is usually in a radial direction. And there can be some, things sometimes, what happens is if your thermal stresses, this may cause change in amplitude and phase with time, So these are some of the things which you have to take care. But primarily, this is the chart which will tell you what are the predominant frequencies which you will see because of that particular type of defect. For example, bent shaft will also generate 1 into RPM, but it will be in axial direction. Similarly, there are several of them. Okay. I think later on I can even send this this presentation or maybe this kind of tabular form available, which I can send it to you individually so that you can have it with you, or I can send it to Mr. Gangalani, who has the contact details of everybody. He can send it to everybody. Okay. So almost every type of defect which you can think about is mentioned here. Okay, different types of machines, different types of defects. So these are the different types of frequencies which are generated by them. So frequency analysis is one of the most powerful tools which are used for vibration analysis. There are other tools for vibration analysis which kind of work together with frequency analysis. So you would have heard probably the names like orbit analysis. You would have heard something called as phase measurement. You would have something called as, there are more complicated jargons like, capstrum analysis, few of them, So these are all there, maybe for more complicated analysis, more complicated machines, more complicated defects. You can employ those kind of techniques. And you can come to a conclusion of, what is the problem with my machine. Okay. So these are the things which are quite commonly used. However, frequency domain analysis is the most common analysis which is being employed. I will show you some case studies. This was one at Myco Industries. Myco, produces a lot of automobile components, right? So there is something called as a fuel injection valve, and this should have a very, very, fine finish. We call it as mirror finish. This particular case, the problem was that there was some kind of a waviness profile, which was not acceptable to them. And the reason was some kind of a vibration of this spindle with the grinding spindle. And this was when the frequency spectrum was taken, The RPM of this spindle was 40,000 RPM. It was a very high RPM machine. The peak which was seen was at almost 4,80,000. I'm just to simplify, I have put in exactly the figure 4,80,000. It was somewhere close to that. And the bearing, there was an anti-friction bearing here. The number of balls, the number of elements, I would say, were 12. You see, it was quite correlated to this. So 12 times 40,000 is 4,80,000, you know. Actually, in practical case, there'll be a little bit of difference. Just to simplify, I've tried to mention it in this fashion. So here, you will be able to identify that there is a problem with the bearing, and you replace the bearing, and you know this was done. I will talk more about this accelerometer a little bit later when I talk about the instrumentation. So this is kind of a sensor, and this sensor was used to monitor vibration. Okay. The another one. This is in a steel plant. It was a gearbox which had a problem. One of the tooth was missing. And this could be identified by trending the values of gear mesh frequency. See, when the gear meshes with each other, it generates a gear mesh frequency. If you monitor that, I mean, this is related directly to the number of teeth that you have. And then with the trending level, it was found that the tooth was initially cracked and finally the tooth was broken. So this could be found out and this could be analyzed. And you could predict, you know, by which time the tooth will break or there will be a problem. So this was done, and then, you know, this could be analyzed. There's one more. Reliance Industries at Patalganga. They had an electrical motor. Now, in this electrical motor, which normally happens, you know, you have electrical motor used in the mechanical, you know, let's say coupling to something or some mechanical machine. So whose problem is this? Is it electrical department or mechanical department? Which maintenance department should take over? So, for example, you have vibration. You need to find out whether it's an electrical problem or a mechanical problem. So in this case, very simple vibration meter. You don't need an analyzer. In fact, a very simple vibration meter with analog meter, you know, moving coil meter is good enough. So here, what you do is you run the machine. Machine is running. You mount the meter, or you know, mount the sensor, and you monitor the value. For example, the value is 8 millimeters per second, and then you switch off. If you switch off the power, if the value comes down immediately, then it's an electrical problem. Whereas if the value comes down gradually, as with the machine speed, then it's a mechanical problem. So this kind of an distinguishing of which kind of problem it is can be done by a simple vibration meter. There's one more. Mumbai Municipal Corporation. You would be surprised, or you already know probably, in Bhandup, in Mumbai, there is a big pumping station. There are 14 big pumps. Each pump is pumping about 110 million liters per day. 110 million liters per day is the capacity of one pump. And they pump the water to part of Mumbai city. So they said that if the pump fails, then we have a problem because the water supply will be reduced. In fact, out of 14 pumps, I think they run at a time something like 10 or 12 pumps. So 1 or 2 pumps are always on standby. But that's a big problem if the pump fails. Now, in one of the cases, they had, in fact, this study was done by DT. And in this case, there was a high frequency of vibration, or there was a vibration of high amplitude at this frequency, 1450 CPM. It was in radial direction. Axial direction was very small. If you see, the radial direction is 10 millimeters per second. Axial direction is only 0.01 millimeters per second. And we found that this frequency, this vibration used to start somewhere in the evening time. And then it used to remain for some time. Then in the night time, when most of the, people are sleeping now, by this time, the vibration would go down. And then again, somewhere in the early mornings, it would again have higher vibration. So this was something which was really funny, why was it happening? And finally, we found that it had to do something with the frequency of, electrical frequency. because at the time when the load was increasing, there was some deviation in the frequency. It was deviate from 50 hertz. It used to go a little bit down. And that little bit down was interacting with the number of slots of windings. And this was creating this high vibration. This is how it was finally analyzed. And by then, I think there was some frequency corrector which was used, and this vibration problem was solved. So I mean, there are various such things possible. You need to monitor, we need to analyze, and then you can come to a conclusion what is the reason of this kind of vibration. So these were the things which I could capture. Now I think we can go to the instrumentation part of it. So what does a vibration analysis system look like? Okay, I've just tried to pick up some simple block diagram. I will also show some more into it. So it can have something which is a pickup or a sensor, and it may have a small cable. It will have some kind of an analyzer or a handheld device. This device may have some memory, so you can store what you are monitoring. These days, you also get what are called as intelligent vibration analyzers. So these analyzers can be intelligent enough to tell you, more or less do the automatic analysis. It can tell you 80% chances that this is unbalanced, or it can tell you that maybe 90% chances that this is misalignment, something like that. So this kind of intelligent analyzers, handheld analyzers are available. And then, of course, you can connect them to the PC. You can download all the data. You can download the reports. You can, generate the reports and things like that. And of course, you can print them and, So this could be a simple block diagram. What you do is you will mount the pickup like this, let's say on the bearing housing, because bearing, takes the complete load of the machine. So this is the most sensitive point where you can capture the vibration the best. So you can pick up the vibration there, and then this is getting converted. The mechanical vibration is getting converted into electrical quantity, and using that cable, it gets transferred to the analyzer. And then on the analyzer, you will see the time waveform, you will see the frequency waveform, you will see the overall value, etc. Okay. So if you see the first part of the this measurement setup is a sensor, and now sensor plays a very important role. There are different types of sensor. The one which was first identified or first I would say designed or invented was called as a vibration pickup, which was primarily a magnet which was suspended inside a coil, and then this plunger which is attached to this magnet will be pressed onto the machine, and this will start vibrating. Because of this vibration, this magnet vibrates inside a coil, and this will generate an EMF or a voltage or a charge or a current, and this is what is proportional to your vibration. Now, this is what was there. It remained there for quite some time. It used to be a bulky pickup. I still remember early days, people used to have one person to hold the pickup, one person to hold the equipment, and the third person to write the reading. This kind of a scenario used to be quite common. So this is what is called as a vibration displacement pickup. Why? Because the voltage which was generated out of this was proportional to vibration displacement. And that's why it was called as a displacement pickup. The drawback of this was this spring, which is, holding this magnet. After a while, you will see that the stiffness of the spring changes. That means you need more frequent calibration of this pickup. And ultimately, it's some mechanical movement inside. So it used to be a problem. The bulk was a problem. They modified some design of this. Then they came up with what was known as a vibration velocity pickup. Again, because the output was more proportional to vibration velocity. That's why it was called as a velocity pickup. And then the current one, or since last many years, of course, now, what is most popular is accelerometer. Now, accelerometer, as the name suggests, the output is proportional to vibration acceleration. And what it uses is this piezoelectric crystal. I am sure that everybody is knowing piezoelectric crystals. This is what you are wearing in your watches, in your in your wall clocks these days. Everything is using the piezoelectric crystal. And the beauty of this is that if you subject this crystal to mechanical force, it generates the electrical output. And if you subject this to electrical voltage or electrical charge, it generates mechanical output. So what is used in the clocks, something similar, which is, applying the electricity, that is your battery, which you are putting in your watch, is applying the electrical field, and this will vibrate the crystal, which is seen as your movement. And in case of our application, like vibration, it is the other way around. So we subject this crystal to mechanical vibration, and because of that, electrical charge is generated, which is ultimately proportionate to vibration acceleration. And this will give you the electrical quantity, which you can amplify, which you can work on it, and then generate your vibration amplitude value. You can generate the spectrum and everything, whatever you need. Okay. So this is the most common thing which is available. Accelerometer, it is available in different sizes, different shapes, temperature tolerance. A typical helicopter, for example, I have seen one in Bangalore, in HAL Bangalore. They had that helicopter on the test bed, and they were monitoring the vibrations for the structure. And there they had almost about 250 accelerometers connected to this helicopter. And these accelerometers were so tiny that they were just taped onto the structure. They were using a double-sided tape or single-sided tape to tape this to the structure, and from there they were taking the output to the analyzer to make the analysis. Okay, so they are available in different size, different shape. So accelerometer getting connected to analyzer, and then analyzer can show you this kind of a graph. Now these accelerometers, when you use them, there are different ways to use them. So for example, the simplest one will be that you have some kind of a pointer or a stud with which you can hold it by hand. This will be the quickest way to do it. However, there will be a small problem. The usable frequency range of this accelerometer will be around 2 kilohertz. The same accelerometer, if I use a magnet and mount it, the usable frequency range goes up to 7 kilohertz. And if I use this accelerometer by cementing it, by using some cementing stud and then mounting the accelerometer on that, my usable frequency range can go right up to 28 kilohertz. So the same accelerometer, but different mounting methods will give me different frequency. Now, the first one, that is a contact point, is the easiest and fastest. The cementing stud will be the, it will take longer time, but this will give you higher range, whereas the contact point will give me the lowest range. Most commonly, people use the magnet so that it is intermediate somewhere. And most of the times, this 7 kilohertz will be good enough, unless you are monitoring very high frequency components like bearings or some high speed machines and things like that. So these are the different ways the accelerometers are mounted to take the vibration reading. Okay. A little bit more into this to give you some idea. I will draw this. This is, let's say, a vibration meter. So you get a very small voltage or a very small current from the sensor. So you need to amplify that. So you have an amplifier. Then normally you want to cut out something which is extra. So maybe if you are analyzing one machine, one particular problem, and you would like to probably filter out the additional noise which is there. So you may have a filter. Or in olden days, they used to have a tunable filter. So it will filter out all the frequencies except one. And you can then do the frequency plotting. You can say my tunable filter is at 50 hertz, then only 50 hertz component is red. Then I put it to 100 hertz, then only 100 hertz component is red. So manually, you can see what are the different frequencies present. Now, if you're using an accelerometer, if you have an integrator, you will get velocity. If you bypass the integrator, you will get acceleration. If you use 2 blocks of integrators, you will get displacement. And to get it to the digital display, you will have an A to D converter, and then you can see the digital value of the vibration meter, vibration reading. Now, if you convert it to an analyzer, then the initial block will almost remain the same. Then you will have some kind of a computer or a microprocessor, and this will have a digital signal processor because you're doing a lot of calculation, and then finally you display it as a graphic display. In today's terms, maybe in this particular microprocessor kernel, you will have some intelligence built in, and this will decide, or this will give you an idea what is the defect directly. It will prompt you to the defect directly. In very advanced analyzers, you also have what is known as intelligence based on neural networks. So these neural networks think like what humans think, so it will keep learning. In many of the softwares, these softwares are separate. These are on the PC, and this keeps learning as the time goes. And then it will give you more accurate and more accurate analysis as the time passes. So these are the possibilities on doing the vibration analysis. You can also have something which is a large facility. You can have online monitoring. These online monitors will directly transfer the data using the let's say Ethernet networks today. And then it can be, like the analyzer or the analyst or the expert is sitting in one place somewhere in the world, connected by the Ethernet or the internet. And then, you will be able to do the analysis at different, collect the data at different places, analysis at a different place. And then, the entire facility can be monitored. So these are the different possibilities. Then maybe you get some kind of a display on the software, which will tell you that, okay, all these green ones are okay. Machines are all fine. Red ones are in problems. Yellow ones are in alert. The gray ones are not monitored, something like that. Yeah, so such kind of analysis is possible. So, gentlemen, this is what I had to say about vibration monitoring and the predictive maintenance. Now, I would like you to ask any questions you have.
Can unmute yourselves.
You can probably, one by one, or you already have put in something in the chat box.
Yeah, there is one question. Is there any difference between ferrography and wear debris analysis?
Yeah, I would say that, they talk in two different ways, but ferrography is limited only to the ferrous particles, whereas wear debris analysis is for any other particles also. For example, your piston is made of tungsten rings. This cannot be analyzed using ferrography, but the basic technique is same. So in case of ferrography, you have the size and shape. I would say size, shape, and the concentration. Similarly, in case of wear debris analysis also, it's size, shape, and concentration, which will give you the idea of how severe is the defect and what should you do. Ferrography equipment will be cheaper as compared to the other one. Does that answer your question? I hope.
Yes, sir. Thank you.
Any other question?
All can unmute themselves.
So one of my professors, please.
Hello. Yeah, Mukesh.
Yes.
Kailash here. I just want to know what is the, this is beautifully explained by you, and but I just want to know what is the kind of planning and scheduling that needs to be done for predictive maintenance?
Yeah, primarily what you do is, depending on the criticality of your machine, you will say that, okay, this machine is very critical and I would like to monitor it more frequently. And the less critical machines, I will monitor less frequently. Okay, so depending on the criticality of the machine, you will have to define how frequently you want to monitor. Normally what happens is that today you might be very cautious. So let's say you install a new compressor and you feel that, this is a very critical machine to my plant. let me monitor it every 15 days. But after a while, you will find that, there is not much of a change in the values. Then you can say, okay, I will now, let's say, instead of monitoring every 15 days, I will monitor it once in a month. Yeah. So after a little bit of fine tuning, you will be able to come to a frequency of monitoring, how frequently you would like to monitor. This is what you can decide. And for example, in a big plant like a refinery, for example, let's say in Indian Oil Corporation, Baroda, which I was associated for quite some time, they would monitor machines, again, depending on different types of machines. Some machines are monitored once in a month. Some machines were monitored once in a week. I mean, so the varying type of monitoring they had planned. And there were two guys, two equipment. Their job is only to collect the data. So they will come in the morning into their department, load what is called as, they call it as a route loading. That means the software will, on the software you plan what are the machines you are going to monitor, and you will download those machines on your data collector. You will go to the field, collect the data. So by the time they finish collecting the data, it is lunchtime, they come back. Those days, the memories on the equipment used to be not very high. So they would then download all the readings which they have collected onto the software. Again, they will go in the afternoon to collect the data. So they were not even analyzing, they were only collecting the data, and then somebody else sitting in the lab, she will do the analysis of the data which has been collected. So depending on, again, the machine that you are monitoring, you will have to find out what is the frequency of monitoring, and that's about it. And these days, I think all the softwares which are available, they will help you quite a bit to collect this data. I think Dr. Pine is also there in here somewhere.
Yes, he's there.
Yeah. Dr. Pine, I remember him, from 3 different companies where he has, implemented this condition monitoring techniques. First was in the plant, which was a copper plant. He was with Reliance in Jamnagar, and then within steel industry, Ispat. So maybe Pine Sahib, you can say something about how you were monitoring, or what were the schedules which you had to monitor.
Yeah, there is no hard and fast rule for scheduling. Once you learn about your machine and its a vibration trend, you can select your scheduling time. Say even where compressors, turbines, alternator having very critical equipments, those are having already online system. Even then, we are monitoring casing vibration also weekly basis. This only add value to a specialist. Not only online data he is getting, besides that he is getting casing vibration data also, that add in analysis actually. So over the time, like ID fan, FD fan, boiler feed pumps and all these, these are every 15 days you can take it. But wherever there is a criticality of the machine, so once you are monitoring, you understand your machine, and sometimes in a week, maybe 2-3 readings are required. When you think we are not able to stop the plant, and management want to prolong it or not right now for a week or so, that time you have to take remote more frequently. But okay, I have worked in golf also, a large company like Sabic and all. They are having once in a month because they want to squeeze to manpower reduction. Generally, all manpower coming from our India or Pakistan or so. So they want to reduce in manpower reduction. So they used to keep monthly once, once in 3 months, even ID fan, FD fan, which we are surprised to see that there. We cannot afford like that in India. So they were doing it, but again, it is up to you how best you train and understand the equipment behavior, and accordingly you can see. There is no hard and fast rule for this. Every company has got a certain logic, frequency logics, and they create a SOP, standard of they keep a SOP for vibration monitoring itself. I have a copy. If somebody wants, I have prepared for some plant, I can share with them.
Thank you, Mukesh ji and Dr. Pine.
Dr. Pine.
I can see Mr. Hariharan. Hariharan, can you listen to me? Hariharan. Can you unmute your mic?
How are you?
I am good. Where are you?
I'm at Coimbatore now.
Oh, very nice. You got our message.
Yeah, I got the message, but that there is a typical error. The password
Yeah,
was
yeah.
wrong.
That is why we sent a resend, and that is why
That
you
I
are
have
here.
not received. That I have not received. So
Okay.
some of them had referred me immediately, telephoned and got it and passed on to many. Okay.
Mukesh, me and Mr. Hariharan had worked some 20 years back together.
Oh, great.
And I luckily saw him, and then I recognized him. Nice to
Okay.
meet him after a very, very long time.
And that is why I put on my video so that people can see me. No?
Yeah, that's good.
Ken Gupta, we had worked together. Na? Ken Gupta.
You are in Century Textile, I believe.
Yeah, I was with Ken Gupta. Ken Gupta was my engineer.
Yeah, Ken Gupta was there. And you are into more of a QMS, and that is why we were interacting during BI's day. Very nice to see you. Thank you for coming.
Thank you, sir. Thanks,
And from Maharashtra chapter, on behalf of Maharashtra chapter, I thank all the guys who have come here. And Mukesh, it was really a good, very technical presentation.
Correct.
And you have explained in a very simplified way. And most of the people who have understood, although it is a very, I will call as a very specialized subject, and you have taken efforts to explain everybody. So from my side, we are very happy. And there are people who have, whosoever here is very actively interested in maintenance part. Like my friend, Mr. Gupta, Mr. Hariharan. These are all very old people. We work together and we have come here together.
We used to conduct this 2 days or earlier even 3 days program, which we called as Advanced Predictive Maintenance Program with NITI from IIT, and NITI was jointly conducting this program. And I think Professor Krishna Kumar has just put in saying that, you have condensed a 1-day program into 1 hour. So this is how it was. I was trying to see that, okay, we give a glimpse, we give an idea. This is more of an idea. And the subject is big. This subject has a lot of things to learn. And yes, if there are enough interest or something, we have, I think, a lot of learned faculties available. Like Dr. Pine is a very practical man, and we spent a lot of time on vibration monitoring. We have Mr. Reddy, A.K. Reddy, who is not here today in this, but Mr. Reddy has also been a very good faculty for us during our programs. So he's currently located in Hyderabad. I mean, we have enough of, I would say, masala available. And we can definitely make it as a 1-day program or something, depending on
we can have a panel of experts and bring all together and do a discussion. Your lecture is listening one, but getting to question answer is.
I think once this, right, sir? Yes, please. Who is speaking?
Ari Ganglani.
Yeah, Ganglani.
Ari Gangadhar is wants to ask some question. He's from Visakhapatnam.
Sure.
Yeah, we have replied him.
He shows his hand. I think he wants to ask some question.
Okay. Tell him to speak.
Mr. Gangadhar, you can speak.
Good evening, sir. Gangadhar.
Are we Gangadhar?
Sir, what will be
from Visakhapatnam?
Hello. Yeah, I am speaking, sir. Hello.
Yeah.
Can you hear me, sir?
Yes. Please continue.
Sir, what will be the amount of difference in vibration magnitude from one accelerometer to another accelerometer?
You mean to say 2 different types of accelerometer, or you want to know about if I mount it at different places, what will be the difference in magnitude?
No, sir. With when I am using, we are getting different vibration magnitude. How far it will be tolerance limits are acceptable from one accelerometer to another?
No, see, I have still not got your question correctly. You mean to say that if you have one type of accelerometer, let's say accelerometer number 1, and you take a reading and you have a particular value. Yeah. Now you put in another accelerometer, which is accelerometer number 2.
Yeah.
And you see a different value.
Yes, sir.
Now, in that case, there will be 2 things. One is the frequency range of this accelerometer. If you are using a different type of accelerometer, maybe the frequency of this accelerometer would be different than the accelerometer which you use second. So then there can be a difference in value. Otherwise, depending on the accuracy of that accelerometer, if you have the same type of accelerometer or the same model of accelerometer, then it should be showing you the similar value, plus minus the accuracy of the accelerometer. Does that answer your question or no?
It is answered.
Okay, Mr. Roy.
Aji.
I feel most of the questions are over, and you have done a recording. If possible, we can share the recording
Yes,
for wider
yes.
And anyway, thank all the participants, and you can close the meeting because we are almost 1.5 hours, 1 hour 45 minutes.
Okay.